Welcome to Relay Chain, a podcast produced by Parity Technologies, where we discuss all things Substrate, Polkadot, and Web3. Welcome, everyone, to another episode of Relay Chain. It's a pleasure to have Joe Petrowski with me here again. Most of you probably already know Joe from previous episodes, but today we are going to talk about one of the projects that he's been working on these past few months, and that's called Statemint. And some of you might have heard of it already. It was the very first parachain to be onboarded onto the Kusama network. And the name for that parachain is actually Statemine, but probably for the rest of the episode, we're just going to refer to it as Statemint because that is the main project that will eventually be on Polkadot. So Statemine and Statemint are interchangeable names, essentially. So moving forward, that's what we're going to talk about. But how are you doing, Joe?
Awesome. Thanks for having me on the podcast, Jorrin.
Oh, it's a pleasure always. Okay, so let's start digging into it, but let's start with like a very high level. What is Statemint?
Yeah, so Statemint is actually a very simple parachain. There's actually not much fancy in it, like what's in the relay chain or what you might think about as like on smart contract parachains or smart contract chains in general. It is basically a parachain for the creation and management of assets, both fungible and non-fungible. So kind of the main stage, as we call it, of Statemint is really just two substrate modules. So one of them is called assets, which handles fungible assets, and the other is called uniques, which handles NFTs, so non-fungible assets. And everything else in there is just kind of like the operational stuff, like those accounts and balances to kind of have accounts so that you can hold these assets, and then some like cross-chain messaging stuff, proxies, multisigs, all those kind of utility features that you expect in a substrate chain. But really like the main feature that this has is the ability to create and manage assets on chain.
Awesome. So when you mentioned like tokens and NFTs, to try and kind of draw a corollary for folks that are maybe more familiar with the Ethereum space, is this kind of like a token standard or a parachain of token standards, maybe similar to ERC20 or ERC721 for NFTs? Is that kind of what we're talking about here?
Yeah, exactly. So these two palettes actually have a very similar interface to ERC20 and ERC721. And the main difference here is that when we talk about like ERC20, I'll just use that one because rather than saying them both for brevity, the ERC20 is like an interface, right? It just says you need to have these functions in your contract. But actually, every ERC20 on Ethereum uses a different implementation of that interface. So you could have some function like transfer, and one contract could actually use a lot more gas than another. So we see this kind of like wild deviation of like gas prices to do the same operation on different ERC20 tokens. And in Statemint, this is actually all just like coded into the runtime itself. So there is a function on the chain called transfer, another function called create to create an asset, and all of the logic is on chain. And the advantage here is we've benchmarked this. This goes through our standard substrate benchmarking procedure where we use some like known hardware, and we can kind of time the execution of these various functions. And then rather than like calculating gas along the way, we can kind of just take this like pre-dispatch fee, and we just take a transaction fee before we even start doing this transfer function, which not only turns out to be cheaper, but also a lot faster. Because when you think about like gas metering something, you're kind of saying like, well, what's the next step in this contract? Okay, it's addition. And then how much gas does that cost? 5 units. How much gas do we have left? 1 million. Okay, what's 1 million minus 5? 999,900. Yeah, 5. And then, okay, now do the addition. And so you have all this overhead of like keeping track of the gas and metering it. And when you think of just the word metering in like a natural language type of sense, it's for kind of measuring something that you presumably don't know what it is. And so on Ethereum, we've maybe done, millions of ERC20 token transfers. Maybe for a specific token contract, there's been millions of transfers of that contract. And it kind of brings up this question of like, why would you meter something that you've already measured? You know the complexity of it. You know that it doesn't contain an infinite loop or something. And really like the advantage of a gas metering system and smart contract platform is that you let people deploy untrusted code. But if you've actually had this code audited and reviewed and you can kind of assert formally that you don't have an infinite loop here. And then it has some complexity, like, you have to do like 2 database reads and 3 database writes and, a couple like mathematical operations. We can just kind of say like, this is how much it costs, and we don't need to meter it every time. So it has like a big kind of like efficiency value, but also this lets us do things a lot faster, where we just know, we know what the transfer implementation is. So we can just say like, well, we're going to put like this many of them in a block rather than have to gas meter it.
Awesome. That was a great overview there. So it's very clear that it's for efficiency's sake that we have Statemint, but why else would we want to create a separate parachain for this kind of purpose? Why not have it on the relay chain?
Yeah, so over time, we actually want to get pretty much everything off the relay chain. We don't want anything to be on the relay chain. So maybe some people have seen this term of like hermit relay chain thrown around, or transactionless relay chain, where we don't have any transactions on the relay chain and everything gets moved to parachains. So rather than talk about assets specifically, we can just kind of talk about this broadly speaking. So if you look at kind of how parachain validation works, all of the validators get split up into these subgroups. So I think our original thinking was like 10 validators per parachain. And now we're thinking we could even go as low as 5 validators per parachain. So if you have 1,000 validators in a network, then you could have 200 parachains, at least as far as these subgroups go. So there's some other issues like networking and other stuff that comes up that could become bottlenecks. But for the sake of like the theoretical validation stuff, let's just say 5 validators per parachain. And these 5 validators actually execute the state transition function of each parachain, and then they distribute this stuff around the network. And there's some other validators that do some double checks. So, which I think is like 15 or 20 validators. So let's just say like a total of 20 validators per parachain that are actually executing the state transition function. Whereas on the relay chain, every validator has to execute the state transition function of the relay chain. So when you put some functionality into a parachain, only 20 validators have to actually execute it. Whereas if you put this functionality in the relay chain, 100% of the validators need to execute it. And so where this kind of like becomes an issue is that if we put stuff into parachains, it actually frees up validator resources, because if we have 1,000 validators and only 20 of them need to execute some parachain, that means that 980 of them can be doing something else. And we'd like them to be validating other parachains. So we don't want to clog them up with like assets transactions. We want them to be able to validate something else. So the idea is like everything gets pushed into parachains. And so we're even talking about like a governance parachain and a staking parachain, just so that this isn't taking place on the relay chain. Does that make sense?
Yeah, no, absolutely. So it's like where we're making efficiencies for the token standards, we're also making efficiencies for actual like transaction and validator weight, essentially, validator computational resources. Okay, so that makes sense. So what does this do then to people that want to use the chain? If we're offboarding all of the computation to the edges, does that then make transactions cheaper and faster for the everyday user?
Yeah, so we've actually started out with transaction fees at about 1/10 of what they are on the relay chain. And that includes all deposits and stuff. So if you've ever used like a proxy or multi-sig, you might have seen that it takes like a, let's just say 0.3 KSM deposit in order to use a multi-sig. On Statemint or Statemine, that would actually be 0.03. So we set everything to 10% of the relay chain. So quite a significant savings. It can't really be faster. It can only have its blocks finalized at the same rate that the relay chain is being finalized. So it's not going to be faster, but definitely much cheaper to actually use this in terms of transaction fees. And the 1/10 thing, it was, to be honest, kind of a guess. We just thought, like, hey, this is a lot more efficient than putting this on the relay chain. We don't know how much it's going to get used. So we put it at 10%, but, we still kind of think that over time, as we add more parachains, we could actually get this down to about like 1/50th. So still another 5x reduction in fees and deposits and whatnot, just because it's so much more efficient to put this stuff on a parachain than in the relay chain.
That's awesome. And so the transaction fee is a guess, but it's a conservative guess, and it might actually get even cheaper. That's amazing to hear. I always love to hear cheaper transactions. That's great. And so I think you mentioned a little bit earlier the concept of a common good parachain. So Statemint is a common good parachain, and it's the very first common good parachain. Can we unpack that a little bit more and talk about what that really means?
Yeah, so a common good parachain is, generally speaking, a parachain that gets added via the relay chain's governance. So as people might be aware, Kusama and Polkadot have quite extensive governance features, and this thing called a root origin that can is basically like a super user in the system, and only governance can access this super user power and kind of access these privileged functions. And one of them, of course, is to register a parachain. So actually, when we think about registering a parachain via auction or as a common good, a lot of people actually get confused here because who can call this like register parachain function? And actually, it's really only like governance that can call this. It just happens to be that as part of the auction procedure, when the auction logic finishes, it autonomously calls this register parachain function from the internal auction logic. And so it's actually the same function being called, just one of them is directly via governance and the other is as a result of the auction logic itself, which is initiated via governance. So in some effect, all parachains are added by governance. It's just that the common good ones kind of bypass this auction process, but everything is still kind of ultimately calling this like register parachain function. And so I can't really control what governance does. I'm sure they can, choose to register some parachain that I might not think fits my conceptual model of a common good. But I would say, generally speaking, I think about common good parachains as being in two categories. So one of them are these system level chains, which Statemint is not. And the other is public good chains, which Statemint is. And so start with the system level chains. And these are kind of what we'd consider really unopinionated logic. So this would be stuff like balances of dot or KSM or staking or governance, and just simply moving these from the relay chain to a parachain. And I say it's unopinionated just because by the fact that the relay chain actually has this functionality, the governance body has kind of, through its runtime upgrades that have led it to this point, have decided that Polkadot as a network should have this functionality. And adding a system level parachain really just moves it from one place to another. So staking was in the relay chain, now it's in a parachain, still the same staking system, still the same staking logic. And the fact that we've moved it to a parachain, it actually makes room for more parachains. So I know like our kind of original white paper said, Polkadot could support about 100 parachains. I think what people should realize is like, that's kind of a guess, right? We don't know how many parachains it can support. Some of the researchers have kind of thrown out like even over 1,000 parachains. We just don't know. And so according to this logic of before that, like, if you have some transaction in the relay chain, all of the validators have to execute it. But if you have some transaction in a parachain, only a very small subset of the validators have to execute it. For some of this logic, we could actually move it outside of the relay chain, because part of the relay chain state transition function is to actually update the headers of all the parachains, right? Because it's like the header data of all the parachains that's going in the relay chain. And that's a database write. It has to write in like, parachain ID 2057 has this new block header as its finalized block. And that takes time. So if we take these like staking and governance transactions and whatnot and move them into parachains, this actually gives those validators more time to add more parachains. So if you think about like 100 parachain limit, adding a system level chain doesn't just like take one of those 100 pieces, right? It takes one of those pieces, but then we say, well, instead of 100, maybe now we can have 120 parachains because we've just taken this extra computation that all of the validators were doing in order to do staking transactions. And now they can actually process more parachains instead of doing those staking transactions. So that's why I call them unopinionated, is the logic is already there. Everyone agrees that Polkadot should have this logic. And we're just moving it from the relay chain to a parachain. And that's an optimization. This other category of public good chains, this is adding new functionality. This is a little bit different than a system level chain because functionality that didn't exist. So that's where like Statemint comes in. It has assets, fungible assets, and NFT, and the relay chain doesn't have that. So this is strictly not a system level chain. And so public good chains come in as features that maybe it doesn't make sense to like build a token model around, or maybe it does, but you could use dot or KSM as that token. And it's something that a lot of people will want to use and harness, but maybe they don't want to like build it themselves, or maybe they just want to like use another chain for it. So you can think of like a smart contract chain that uses DOT to pay gas fees, Statemine for minting assets. So if you think about like the evolution of an asset standard, it might make sense to just have like a Polkadot asset standard rather than like waiting on some other parachain to come along, and it might just be like the first one that wins an auction and gets to mint assets or whatever. So this is kind of like a network token standard, or maybe like a better example is even bridges. So bridges to Bitcoin or Ethereum. It doesn't make sense to have 4 different bridges to Ethereum, or one of them might have a token and say like we have a token model around our bridge, but they have access to DOT and they have access to ETH. And why would they add another token as basically like a toll? That doesn't make sense for the user. It just kind of complicates things. And so I think like just having like a bridge where we say like, you know what, everybody agrees that a bridge to Ethereum is useful. Let's just give this a slot in exchange for, maybe we can, have been going on for a long time now. Maybe we can just dive into like a little bit of the governance stuff and like some of the longer term implications of what it means to be a common good parachain.
Yeah, I mean, like there's a lot of there that I think I'd like to dig into. And I think we kind of glossed over when we were mentioning about Statemint being a common good parachain. And then you just kind of reiterated that these are for typically going to be for chains that might not have their own native token. So Statemint is one of those instances where it doesn't have its own token and it uses the native token of the relay chain, whether it be KSM for Statemine or DOT for Statemint. So how does that work then?
Yeah. So we have this kind of special category of cross-chain messages called teleports. And so we just basically say on the Statemint or Statemine side that we trust the relay chain, which is pretty much a given for most parachains. They should trust the relay chain since it's providing their finality. But it basically says, if the relay chain sends us a message that includes some KSM, rather than minting that as like an asset under the assets palette, we're actually going to mint that to an account under the balances palette. And so other chains might do a different thing. So if we look at like some of the community chains that are smart contract platforms or something, if you sent KSM from the Kusama relay chain into those, they already have their own native token under the balances palette. So they might actually mint KSM as some other kind of like, even like ERC20 type of token. Statemine just says, oh, if we receive KSM from the relay chain, then we're just going to mint this under the balances palette and use that. And then likewise, going back from Statemine to Kusama, that's actually where it becomes a bit more complicated because the Kusama relay chain doesn't trust everybody, right? Because all of these parachains have their own governance systems, generally speaking. Statemine doesn't really. It kind of says like, hey, like the Kusama relay chain is my governance, but there's other chains that might have pseudo in them or some other kind of governance. And so the Kusama relay chain doesn't want to trust necessarily the KSM that it gets back from them. So it's going to keep track of like, okay, like I've sent, 1,000 KSM to parachain A and 2,000 KSM to parachain B, and I'm not going to let them send back more because those parachains could like mint KSM as some other token, mint more of it like under pseudo and then send it back. And so the relay chain doesn't want to accept more than it's sent out. So it wants to track like how much KSM kind of exists and where. With Statemine though, because it doesn't have its own governance system or it outsources its governance to the Kusama relay chain, the Kusama relay chain can kind of trust it, right? Because Statemine's governance is Kusama's governance. So they're both under the same body of stakeholders. And so the relay chain can say, okay, well, like if we get KSM back from Statemine, we can actually trust that. And so I think it's called like the trusted teleporter. And there's something in the runtime that just says like, well, these parachain IDs are trusted teleporters, so we'll accept KSM back from them. So in that sense, like KSM on the relay chain and KSM on Statemine, they're equal, right? Like KSM on Statemine is just as good as having it on the relay chain.
Cool. And so once it's across, then it's then used for the transaction fees to perform whatever you want to do on Statemint.
For now.
For now.
Yes. But in the future, you could actually use the assets to pay transaction fees in and wouldn't even need to have KSM.
Whoa, that's crazy. Is that like in the distant future or is that something like that could be really soon?
That's in the quite near future, actually.
Wow. All right. We might have to have you back to explain how that works. Okay, so we've talked a bunch about how common good parachains are onboarded via a governance call and how speaking for Statemint, the governance of Statemint is delegated to the relay chain governance. So how does that work in terms of like making improvements or like runtime upgrades and stuff like that for Statemint? Is there a governance proposal on the relay chain that gets voted on by DOT and KSM holders, and then that gets implemented on Statemint?
Well, that was an interesting kind of development hiccup on the way to making statements because we had this conceptual idea that statement should basically accept messages from the relay chain at face value. And we wanted to be able to say like that the governance origin, what we call root on statement, is equal to root on the relay chain. And likewise, we wanted the council to have some powers. So there's like this collator selection palette, and then the assets palette that has some privileged functions like force creating an asset and stuff. And so we wanted to say things like, well, the majority of the Kusama council can create an asset on Statemine, or force create an asset. Or in order to do a runtime upgrade of Statemine, we need a full referendum on Kusama to get like the root origin of Kusama. And that's kind of simple enough on one chain, but the Statemine runtime, as I said, is very simple. It just basically has like accounts or balances and this assets and uniques palettes. And it doesn't have the collective module that represents council or technical committee. It doesn't have the democracy origin. It doesn't have any of these kind of like primitives around governance. And so we basically had to find a way to express to the Statemine parachain that the root origin of Statemine is actually the root origin of Kusama, or that the asset's privileged origin is greater than 50% of the Kusama council, which still sounds kind of like quite simple in theoretical terms. But you're basically telling this chain, hey, there's this other blockchain out there called the Kusama relay chain, and it's kind of like your parent. And it has this thing called a council. And if more than 50% of them get together and send you a message, then you need to respect it as this like assets privileged origin. And of course, like Statemine doesn't even know about this like collective module. It can't really reason about that. And so kind of creating these origins that allowed that to happen, it required some new features in cross-chain messaging and the council logic and a runtime upgrade actually on the Kusama side in order to make this possible. So it was pretty neat. And now we have these origins where we can say like, you know, that some other chain has an executive body, which we call the council, but you could have other types of executive bodies, or that you would have like a stakeholder referendum and you need like the majority of all the voters to approve something. And so we can now kind of say that like, okay, yeah, trust me, there's other blockchain out there and they have this collective executive body and they can send you messages. And that's pretty neat. So in order to do these like runtime upgrades, yeah, it takes a general referendum. So usually these kind of get accelerated by the council, but still go through like a general stakeholder vote where the whole community has a few days to vote on things. And then we'll dispatch a message with the actual instructions to Statemine.
Very cool. Okay, so Statemint was built in large part by a collaboration of Web3 Foundation and Parity Technologies. Are most common good parachains, do you think, going to be built by that kind of collaboration, or are there like third party, so to speak, projects working on common good parachains as well?
Well, I think it's going to be a mix. So probably Parity and Web3 will work together on a lot of the system level stuff. So, you know, Parity implemented the runtime that's being used on Polkadot and Kusama now. So when we talk about like just taking this runtime and breaking it into more modular pieces, like a staking runtime and a governance runtime and whatnot, Parity already did the implementations of those runtimes that exist. So it kind of makes sense for them to just kind of like break those out and make them into system level chains. As far as the other chains go, the public good chains or public utility chains, we've actually seen quite a huge mix of like ecosystem teams who want to contribute. So we have a couple different teams who are doing bridges. So we have like the Snowfork Ethereum bridge. We have the Interlay Bitcoin bridge. There's some others. So there's been like a proposal from Encointer as a common good parachain on Kusama. And I think that's like up for discussion on Poke Assembly and all the other forums right now even. And I think like Paytrax has submitted a proposal for something that's still kind of like preliminary. But anyway, like there's been a ton of interest from teams who have wanted to build common good parachains and have made some arguments about like why their parachain should be a common good chain. So I actually think it's going to be quite a big mix of teams who want to contribute to building this.
That's awesome. I really like to see that kind of buy-in, so to speak, from the community, because in a lot of cases, building a parachain is very expensive. And I guess the payoff in most cases for these teams is that they'll have their own token, which will generate some return on investment for them. But in this case, most, if not all of these parachains will be powered by DOT and KSM. So there's no real, I guess, direct line of ROI for that. So I think that's pretty awesome. In terms of collators and validators for these parachains, what would be the incentive for them to participate and support the common good parachains?
So that's a good question because it kind of gets into this incentive thing. It's using DOT or KSM as its native token, but it doesn't have any information about staking or governance. And, staking is kind of like where inflation comes from and whatnot. And we've also said that like the transaction fees are only 1/10 of what they are in the relay chain. So we have no inflation, no staking rewards. We don't even have staking really. I wouldn't call it that because there's nothing at stake. And the transaction fees are very low, absolutely minuscule compared to what you would see on the relay chain. And so the question is kind of like, well, who would want to run these collators and whatnot and actually collect these transaction fees? And we've actually seen a surprising amount of interest. When we launched Statemine, we launched it with kind of like a permissions collator set, just because, Cumulus was at like the 0.9.4 release. So like we don't have a Cumulus 1.0 yet. And we're still kind of like discovering issues with the collator node implementation and trying to do like rapid updates and stuff. So we kind of launched with this like permissions collator set. So it's kind of small so that we could apply these updates in a quicker way and make sure that we fix anything. And there's been a lot of requests to open this up and a lot of people want to participate. And so I think that's awesome. Like there's definitely an element of like people who just want to learn more about running these parachains from a DevOps perspective, like infrastructure, what kind of nodes and hardware is needed. But also these are providing like pretty core pieces of the Polkadot network. So I'm starting to not even think about like these parachains as being like specific chains to use, but like more of like Polkadot as a network, right? So it's like you wouldn't think about like even Statemine or Statemint as a specific chain. You're just like, well, if I want to like have like represent assets on Polkadot, it would just be under Statement, right? And if you want to like perform some staking operation, it would be under the staking parachain. And actually, a lot of users wouldn't even need to know about these multiple parachains. They could just have some interface that's like, this is Polkadot. And it would actually be like the backends to the UI that would decide like which chain it's making transactions to. So anyway, where this kind of comes back into the collator stuff and like who would run them is like people who build applications on Polkadot. So if you've deployed assets on Statement, or if you're running validator nodes and you want to make sure that people can nominate you and that their nominate transactions actually get included in the chain, you'd probably want to run a collator to make sure that like this chain stays available and that people can access the services that are related to your application.
That's awesome. Yeah, so that makes a lot more sense. It's this game theoretical model. People are generally most inclined to do something that benefits them. And so if your application relies on the robustness of Polkadot in general, then it makes sense for you to support these parachains as well. That is awesome. Okay, so we've talked a lot about Kusama or Polkadot interacting with Statemint and Statemine, but how does Statemint interact with other parachains?
Yes. So this is interesting. There's a lot of ways that it interacts with other parachains. So
I saw a presentation that you did talking about two ways to use Statement. One of those ways is sending assets between Statement and other parachains, and then sending the side effects from a parachain to Statement. Maybe we can put it into that kind of framework.
yeah, sure. This kind of goes into like the whole synchronous versus asynchronous application conversation. So far, blockchain apps have been pretty much entirely synchronous. So if we think about Ethereum as a network is basically a single threaded computer. And so everything that takes place there is synchronous. So if you have some application that's a contract and it interacts with other contracts, it's going to call those other contracts, wait for them to successfully finish before moving on to the next call. Pretty standard. Like if you're familiar with like computer programming, this is like just a very simple single-threaded synchronous machine. And so each parachain is like that itself. So like if we just look at like Statemint, it's synchronous. If we look at a smart contract parachain, that's synchronous too. But the messages between parachains are asynchronous. So these actually get dispatched at the end of a block, not mid-transaction. So if we think about like the not just like one transaction, but if we think about like the execution of a parachain block and what that looks like, it's going to start out with like the block initialization, go through all of the transactions, and it's actually going to kind of collect all of the outgoing cross-chain messages. So you might have like, let's just say on a smart contract parachain, you have a block with 3 contract calls in it, and each one triggers some cross-chain messages. So like the first contract that you execute wants to send a message to Statemint, and the second one wants to send a message to the staking parachain, and the third one sends a message somewhere else. It's not like you send the message to Statemint and then go on to execute the next transaction. It's actually going to kind of queue these messages up in like an outgoing queue. And at the end of the block, it's going to dispatch all of the messages at once. So by the time the messages even get sent, that transaction or each of the transactions that trigger them have actually finished executing. So like they're finished, they're done. Like you're moving on to the next block at this time. So you don't get to wait for a response from Statemint. This is pretty standard asynchronous messaging. You send off a message and you just keep going along with what you're doing. So now we kind of get back to this, like how could you actually interact with Statemint or Statemine? And so if we just think about it from like the, say, parachain perspective, like thinking about another parachain and not about a user from like the front end, we can kind of go about this 2 ways. So one of them is that we just say like, well, let's stay in the synchronous model where we just kind of only deal with things synchronously, and we just send some cross-chain message from Statemint to our parachain, and we just kind of like represent the token there. So if we are a smart contract parachain, we might have like an ERC20 contract or a precompile or something on our chain, and we just say like, we put some interface in our runtime that says when you receive an XCM message from Statemint, what you're going to do is like take that asset that's been transferred from Statemint and just kind of like map this onto your version of an ERC20 and have this token on your chain. And then you can go about using it synchronously. So if you have some contract that interacts with these assets, you know, it can just kind of like call your ERC20 precompile or whatever you have and interact with that synchronously. And then at the end, maybe this token kind of in its course of life on the smart contracts parachain, it changes hands to somebody else. And Statemint has kept track of like how many of this asset it's sent to that parachain, but not keeping track of like the user balances on that parachain. So now like another user can send this back to Statemint and have it there, right? So that would be kind of like the, say, naive synchronous way to use Statemint. The downside of this is that we're representing one thing in many different places. So this kind of works if you're just thinking about like Statemint and the smart contract parachain. It's not the end of the world. But when we think about having like, say, 100 parachains or 100 parachains and 1,000 parathreads or something, and then you want to have this asset that gets like sent around in the network, you're actually now representing the same asset like 100 different times. And that's really inefficient. We have this like super efficient parachain that we talked about at the beginning for representing and dealing with assets. And now you're just kind of like copying them in 100 different places in less efficient representations and operating on them in those representations. And so that's obviously not really ideal, although it lets all those representations kind of stay in their mental model of like synchronous application development. So that kind of brings us like, well, what's a better solution? And so that's where this like asynchronous programming comes in. And in this case, like the start of this question, like you have some block that's executing and it just dispatches all these messages at the end of the block. And so you could actually kind of go about this by saying like, well, just like we did with governance, where we said like, hey, trust me, there's this other parachain out there, or not even this parachain, this other blockchain, this relay chain, that's your parent, and it has these governance bodies. And if they send you a message, then you need to obey it. You can tell your chain, hey, there's this parachain out there called Statemint, and it has assets and accounts and all of these things. And so we could do our like contract execution without having those assets on our chain at all. And then we can just say like, okay, here's this batch of transactions that we want to make on Statemint. And you could have, I don't know, 10 transfers, or you want to like do some like asset manager creation or burning type of stuff, right? And you could come up with like this batch of transactions that you say, okay, I executed this logic on my blockchain and I figured out like I want to make these operations on Statemint. And so at the end of my block, I'm just going to send off a batch of transactions to Statemint and say, hey, execute these. And then the assets never actually leave Statemint at all. So you're actually like performing the execution of the transactions in the most efficient place. So that's awesome from an efficiency point of view. It also comes with some like extra hiccups, which is like, well, what if one of those like transactions fails? Then what are you going to do? So this is a lot of stuff that's like being worked out. That's pretty like classic async programming, like what happens if this thing fails. But like, it's pretty simple if like the only state changes are happening on Statements, but like what happens if you assume that everything goes well on Statements, but you're going to also make some state changes on your chain or dispatch messages to other chains and tell them to make state changes. So that's where this gets like a little bit more advanced. You can kind of like imagine running into race conditions where like two parachains have executed some logic that wants to transfer the same tokens on Statements, and only one of them like gets to Statement first to be executed. So there's lots of fun stuff to deal with like that. And maybe like there's stuff like locks, like a mutex, right? Where one parachain can tell Statement, hey, we're doing some stuff on this asset. Can you freeze it? And then we're going to go about our business and then unfreeze it and perform our state changes, because then we'll have some like guarantee that they're going to work. So quite a lot of like interesting stuff that will take a lot of infrastructure and tooling to help people like actually develop in this paradigm on.
Yeah, I think that is a drastic change of the paradigm where we're used to things happening in a direct one after another order. So like you were saying, what if something fails? So that's a huge puzzle to kind of solve. And I guess, as I understand it, we haven't quite fully solved that problem yet, but that's something that we're working on now. So from like a very, I guess, naive point of view, does that mean that if dispatching a batch of transactions on Statemint from another parachain, that there would be some sort of, I guess, to draw an analogy, like a number of confirmations, block confirmations before that would be deemed finalized on the parachain? Does that make sense?
Abstractly, yes, but in the context of Polkadot, no. So
Right.
This is kind of like the strength of Polkadot, is that it guarantees this context that everyone's operating in. So since the relay chain is storing all the block headers of the parachains at some given height, and those block headers include like a Merkle root of all the outgoing messages that it sends, there's really like no way that like you act on a message and then the other parachain gets reverted to a state of not having sent that message, right? So you would also get reverted to not having sent that message. So luckily in Polkadot, final means final, and we don't have to worry about kind of going back on those messages.
Very cool. And that also brings up some issues, like you were saying, with tooling, like for like a block explorer or a wallet. Like, how do you handle displaying data to a user that has accounts across multiple parachains that are at different heights and so forth? I think that's another pretty big issue there, right?
Yeah, so I think there's a lot of stuff here that people almost take for granted. So if you go to a wallet, it tells you how much Ether or DOT or whatever you have. And likewise, if you go to something like Etherscan and you check a transaction that you make, it just shows you like, well, here's all the state changes that were made in this one transaction, right? And it's pretty simple. It's all in one place. And because it's synchronous, everything is kind of contained in that one transaction, right? It's not like something happened elsewhere because of it. So that gets much more difficult in an async environment. So if you kind of like did one of these examples where like we executed something and then it came with this batch of transactions that sent the statement, and those got executed like 1 or 2 blocks later, if you actually wanted to say like, okay, I made this transaction and what were all the state changes that occurred because of it? Well, now you have to figure out like, okay, well, there's the state changes on the chain where you made the transaction itself, but it also triggered this outgoing message that resulted in state changes on other blockchains too. And maybe those triggered messages that caused state changes on other blockchains. And you need to kind of like go about like linking this all together and figuring out how to display that in one place. And then even like a simpler example, like, well, how much dot do I have, right? Because we talked about kind of having like this balances parachain, assets parachain, staking parachain, governance parachain. And you can kind of imagine like having accounts on multiple parachains with the same asset on all those accounts. And so if you want to know like, well, how much dot do I have? Your wallet has to kind of know that it should query all of these different chains and add them up. And, there's not going to be like, at least at the node level, like a single API call that will tell you this. Going to have to kind of like pull it together. And so that's where like a lot of tooling and middleware comes in, is that people need to build things that can actually like, run the infrastructure of like running all these parachain and relay chain nodes, and then saying like, okay, if somebody gives me, to be able to provide this like one-liner API of like, what's the balance of my account, and go figure this out. So there's a lot of stuff. I think this is like a multi-year type of process. It's not like something that's going to be fixed in like a GitHub issue or like a couple of weeks or something. It's definitely takes like years to develop this kind of tooling. And so even a lot of the stuff that I've said here is kind of speculative about like how to go about async programming in blockchain. Is like the thing is we just don't know, or at least I don't know. Maybe there's some people who do know. But I think like kind of starting to develop this really primitive tooling like wallets and block explorers to help people like deal with a multi-chain environment is really important. And it's going to kind of like pave the way for these more advanced applications to actually like be able to handle these async environments.
Okay, so that brought something up in my mind here about having accounts across different parachains. At least in the case for Statemint, does it use the same derivation path as like the relay chain that it's on? So does my account in the same format work as an account on Statemint? So if I send KSM to Statemint, is that how that would work?
Yeah, so actually, this is kind of a funny question because it comes up a lot. The whole address thing is, we use this like SS58 encoding. Is that what you're asking about?
Yeah.
Yeah. So what's actually stored in the state tree, like if you go to the database of the state database, it's going to be the account ID. So in most cases, it's a 32 byte identifier. So you have like 0x, F237, blah, 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 32 bytes. And we kind of like transfer this into these like more human friendly addresses. So like the Polkadot addresses start with the number 1. The Kusama addresses start with like a capital letter, this type of stuff, right? So actually the address, even though it's shorter and more human friendly in character terms, actually contains more information than the account ID itself. So the address actually contains the prefix. So like the SS58 identifier. So like on Polkadot 0, on Kusama it's 2. And then like these other parachain teams can claim them in the SS58 registry. So it has this number as the like first 1 or 2 bytes. And then it has the account ID. So 32 bytes account ID. And then it has a checksum at the end to kind of make sure that it actually is an account. And so when you when you construct a transaction using like Polkadot.js or some other tool, it actually strips away the prefix and the checksum, and it just constructs the transaction with the 32 byte account identifier. So you could actually send Polkadot to a KSM address, and it strips away the whole address thing of like the letters and whatnot, and it just kind of converts this to an account ID. Should make a warning that do not do that with like an anonymous proxy or something. I'm kind of talking about your standard like private key, public key type of accounts here. Don't do something if you don't know what you're doing. But generally speaking, if you have your kind of like basic accounts of like with a private key and public key, then you could just send it to like any address, and the actual transaction encoding strips away the whole like human readable address thing, and it just puts in the 32 byte account ID. And then you can kind of access it under whatever address. So yeah, so like Statemine uses the same prefix as Kusama. So like addresses on Statemine look exactly the same as on Kusama. But that's more for like the human friendly readability component.
Okay, that makes sense. Okay, so we talked about a couple of the challenges with building statements, the delegating governance, the ongoing challenges of like figuring out asynchronous execution and so forth. What other kind of challenges have you faced with building statement?
Trying to remember because there were a lot, but no, it actually wasn't that bad. I mean, it is kind of amazing that we started this project in I think March, and we had this parachain on Kusama in June. So think about like developing, and we had to make maybe a month of that was just kind of the changes that we needed to make to the relay chain itself in order to accommodate the governance issues and whatnot. So really to go from like basically nothing and an idea into a production parachain in 2 months is pretty amazing. Kind of like tooting the parody horn here and whatnot, but like with Substrate, like that's pretty cool that you can just kind of like start from scratch and have a blockchain up and running in just a couple of months in production. So definitely like, in my opinion, the most interesting challenge was the governance stuff and just how do we tell Statement that there's this other parachain out there with a council and technical committee and referendum body and all this stuff, and that you should accept messages from portions of them and do things based on that. I think that's really cool. Some of the other stuff was like this collator selection and like how we deal with transaction fees and whatnot. And that all, of course, got worked out. And I think the launch went pretty smoothly. It actually worked the first time. So did some testing on like Rococo and West End and all of that. And actually had a fairly smooth rollout on Kusama. Wasn't very chaotic. And now, like actually today, we're doing the upgrades to take off like kind of the training wheels and really just let people use this. So it's been a really fun project to work on. And definitely like, I think the next big challenge is this cross-chain messaging. So on the cross-chain messaging, it's going to be very interesting just in like how people actually use it. And we have this idea that like, Statemine should be kind of like the asset home base in the Polkadot network. So I think, like I said, it's going to be like a multi-year project to get this like tooling and infrastructure stuff to a mature state. So I think kind of a lot of people in the early phases are going to use this in more of like the synchronous way where they like transfer an asset from statements to their parachain and use it there. And in that case, like statements kind of keep track of like, okay, like I've sent, it's going to have a lot of assets, but if we just think of like asset A, I've sent like say asset one, because we've been using like parachain A, I've sent like, 1,000 of asset one to parachain A and 1,000 of asset one to parachain B and whatnot. And kind of keep track of like, well, this is like the total issuance of this asset in the entire network. And we kind of know it's divided up. Like we have this much on the Statemine home chain, and we have like this much on parachain A and this much on parachain B and all of this stuff. And people will use it that way. And I think like a really interesting project is going to be like building the cross-chain messaging interfaces so that people can use it in other ways, like asynchronous ways and more trustless ways. So if we kind of think about this like registry thing where like you're keeping track of like, okay, I've sent like this much to A and this much to B, it kind of introduces this bottleneck where like A can't send it directly to B because now the debit and credit thing will be out of sync because Statement's going to think like, well, wait a minute, I sent this to A and now B is saying they have more than I've sent to B, but it's really because like A sent it to B. But Statement doesn't want to like trust the governance of these chains that they haven't done anything funny with it. So this is where like these modules like Spree that we've talked about kind of come into play and enable this like more advanced cross-chain message passing. So like the XCMP version 1 is going to be this more like, well, Statement is like the home base of assets and people are going to use it to kind of like send their assets in and out of. And then like kind of future, like with Spree and everything is going to be with this more advanced, like trustless messaging where like any parachain can send assets to any other parachain and Statement can kind of keep track of this. So I think that's going to be like quite a big challenge, but also really interesting to work on.
Yeah, I don't think we've talked much about Spree yet on the cast, but for those listening, Spree is the shared protected runtime execution environment, something that is on the longer term kind of roadmap for Polkadot to allow parachains to speak with each other in a trustless kind of environment. And we've been talking a lot about today cross-chain messaging. That's what we mean by XCMP, the cross-chain messaging protocol. The protocol parachains use to talk to each other, and Spree is how they can do that in a trustless way. Very cool. So kind of wrapping things up here, we talked a whole bunch about where Statemint came from and where it's kind of at today. What are the next kind of immediate steps that we're going to see rolling out for Statemint?
Yeah, so on the Kusama side, actually today we're doing the upgrade that kind of strips any kind of permissioning. So before today, only the Kusama Council as a body could create assets, and that went for the for NFTs and for fungible assets. And we're doing a runtime upgrade today that actually removes that, and so lets anybody create an asset and manage it and do as they please with it. And then the stuff that's coming up next is working on, first of all, like opening up the collator set so that more people can join as collators. Two, I would say like this XAMP work. So adding in the interfaces so that we can send assets to other chains. So this will still be like a pretty simple early version of XAMP where we keep track of like, okay, we've sent this asset to this parachain and whatnot. So nothing too fancy, but this will allow like sending assets in and out of Statemine. And then also going to be working on this like ability to pay transaction fees in assets themselves. So this won't be all assets, but like kind of at the discretion of the Kusama Council, they can deem certain assets as being sufficient to pay transaction fees. And then you could have accounts that don't have any KSM at all and just have this asset on them, and they could pay the transaction fees in that asset. And then kind of looking a little bit farther down, that's, I think, where we get into like launching on Polkadot and still some like audits and other work that we want to do, like getting Cumulus to be a bit more stable and whatnot before rolling it out on Polkadot. But that is definitely in the pipeline and hopefully not in the too distant future.
Right. That's mainly due to like the kind of model of rolling things out in Statemine being on the more experimental canary network of Kusama, and all the new stuff goes there before eventually making it to Polkadot. And so with that being the case, do you see Statemine diverging at all from Statemint as time goes on? It being, reliant on Kusama governance, could they make different changes for Statemine that Polkadot governance might make for Statemint?
Yeah, it's totally possible. Since the logic is pretty basic, I'd be surprised to see them deviate too much, just because it's basically these two palettes, like assets and uniques. So if we talk about like adding other palettes or even maybe just like changing parameters and whatnot, then yeah, they could diverge. But I think like kind of thinking in the specialization mindset that like this is just a parachain specialized in these things, then it's kind of unlikely that they deviate too much from each other. But it's always possible. I mean, I'm not Kusama Council, so don't have any input there. And maybe they'll go rogue and build some other version of Statemine to replace it. I would imagine they stay pretty similar.
Anything's possible in a DAO, right?
Exactly.
It's very cool. So folks that are hearing this might be hearing it for the first time. Probably by the time it's released, permissionless asset creation will be live on Statemine. So you guys can go out and create your own coins, essentially. I might go make a Jorrin coin. Okay, so I think that's everything for today. I thank you again, Joe, for coming out. Do you have any parting words for folks listening?
Parting words, always tough. No, just check out Statemint, Statemine, lots of links out there, blog posts, the GitHub repo, all that, and lots of exciting stuff coming up for Polkadot and Kusama.
Perfect. Thank you again for coming on and talking to us today.
Yeah, thanks, Jordan.
All right. Take care, everyone. Thanks for joining us this week on Relay Chain. We'd love to hear your thoughts on the subjects we talked about today. So please reach out to us on Twitter @RelayChain or by email podcast@parity.io. The team at Parity has some of the brightest minds working towards building a robust and inclusive ecosystem that puts power back into the hands of its community members. With cross-chain communication as a primary goal, we aim to break down the tribalistic barriers that have formed throughout the blockchain industry. If you want to learn more about what we're building, or if you want to join our team, visit our website at parity.io and sign up for our newsletter at parity.io.